You all are always like right here. The others, I'm like. Y'all remember, we're going to be finishing what we had started yesterday. Remember, we had the last two to do. So that's what we're starting with, number 19 and number 20 on page 522. I'm finished writing this one up here. Y'all got a calculator ready? Because we're gonna need one today because we're changing. Remember, we started it at the end yesterday where you take the information in the tables and we change it to its frequency distribution, which is the percentages. So you need to have that where you can do it. So you all are gonna have to, we have our original graph that's in the book, but then you're gonna have to draw the new one for each problem. Okay, so you're gonna have to draw the new one for number 19 that has male, female total, computer, art, and total. So if you haven't already started doing that, you start doing that. And then on number 20, you got boys, girls total, and cone dish total. Because we're gonna break, we gotta find the percentages to go in there, but you gotta have the table so you can put them in there. Okay, Cesaria, we're going to be on page 522. We're finishing the last two problems from yesterday. So they're working on getting their two tables drawn that we're going to have to fill in with our percents. There, then the glare is kind of over total. I don't know. All right. Okay, so we're finishing number 19 and 20 first from yesterday. And on these, like we did, like I think it was 17 and 18. On 17 and 18, we did what they called the frequency distribution table. And we changed it to, that's where we took our numbers and we divided them all by the grand total and got percents for each one. So we're doing the same concept on 19 and 20, except on 19 it wants to do the conditional probability distribution, which the conditional means you're only doing it based on going across the rows. You can do it by row, or you can do it by column. So it's comparing it for each row or by each column. So on number 19, we're gonna do it by row, and number 20 also says by row, but we're gonna do it by column, just so you have an example of doing it each way, okay? So what you do for this, instead of dividing all these by the 300, you divide the males that have computers by the total number of males. You're going, remember rows go across. So you're going across the rows on these. When it says by row, that means we're going this way, okay? So that's telling you what we're gonna be dividing by on there. So for number 19, for this first number here, for the males and the computers, I'm gonna take the 123 and I'm gonna divide that by the 164. So whoops, helps if I turn on. 123 divided by 164. And you get a decimal, but we always change the decimal to a percent. So when we change that to a percent, it's going to be 75% of the males did the computer, okay? Then we do the same thing. You're just doing it by the row. So you're gonna take these numbers by their row total, not the grand total. So I'm gonna have 41 divided by what?
$164.
4. And get my nice little decimal. And that one's gonna be
25%.
5%, which should make sense, okay? Because this one would take 164 divided by 164. Anything divided by itself is 1, so that should be 100%. So if I add these two parts, it should equal the whole thing, which we talked about that yesterday, okay? But you're going across the row, okay? So now the next one. We're talking about the females. So we're looking at the number of females who did the computer out of the total females. So this is what we're gonna divide by for this row. So you're gonna take 94 divided by 136 and get your little decimal. Now on this one, it's a big long decimal. See, it goes all the way across my screen, okay? Usually for these, remember when we were doing the decimals, we kept 3 decimal places, right? So since it's gonna be a percent, you gotta move the decimal point over 2 places, so you'll be left with 1 number behind the decimal point. So I'm gonna go over 2 places, so it will be 69.1%. Okay, now we do the next thing. We're doing the females that were in the art. So you're gonna have 42 divided by 136. Get your little decimal. Be careful with rounding on this one. That 8's gonna make the 8 in front of it go up 1, so it's gonna be
30.9.
30%. Which remember, these two things hopefully should add to equal
100%.
100%. Because 136 divided by 136 is 1. And it does, so it works. Okay, easy?
Yeah.
Similar to what we did on 17 and 18, except it's telling you it's just focused on doing it by the row or doing it by the column. Okay? So, for the totals, you do the same thing. You're going to take 217 divided by 300. You get your little decimal. That's 72.3%. And then I do 83 divided by 300. And this, it's the 6 repeating. So is that next 6 going to make this one go up?
Yeah.
So it's going to be
7.
27.7%, which hopefully those add to 100%.
100.
Okay, so if you are doing the probability by row, then that means all your row totals should end up being 100%. So when we do our probability by column, our conditional distribution by column on number 20, our column totals are the ones that should end up being 100%. Okay, because we're going to be going this way this time. So on number 20, I'll take 8 for the boys that had the ice cream in a cone or whatever it is. Okay, so I'm going to have 8 divided by 18 because I'm doing by the column. So I'm doing by the column totals. So 8 divided by 18, get your little decimal, and it's 0.444444444 forever. So 44.4%. And again, I'm doing by column, so I'm going to go on and keep finishing this column. So the girls, there were 10 out of 18. So 10 divided by 18, you get your decimal, change it to a percent. It's going to be 55 point what? Really, that's good. If all of them are 5s, is that 5 going to make the number in front of it go up?
Yeah.
Yeah, so it's going to be 55.6%.
6.
If I add these together, this is 99, and then 0.4 and 0.6 is in 1. So remember, your total should be 100% in your columns this time. You're doing it by column. Okay, column, remember, you're going this way. So for this one, boys that got their ice cream in a dish was 5. 5 out of 9. So 5 divided by 9, you get your decimal. It's the 0.5 repeating, so it's going to be
55.6.
Then I have girls had it in a dish, so it's 4 divided by 9, so it's going to end up being
44.4%.
44.4%, which adds to
100.
100%. And then for the last one, there were 13 points total. So 13 divided by 27. You get your decimal. Oh, I hit another number in the front, so it gave me this.
48.1%. Or 48.2.
Okay.
48.1%.
Yeah. Okay, because it's 481, 481, 481, but the 4 is not going to make it go up. Okay, that was right. And then for the last one, you have 14 divided by 27. And you got 518, 518, 518. So is the 5 going to make the 8 go up?
Yes.
Yes. So it's going to be 51.9%.
0.9%.
So it should add to equal
100%.
So when it's talking about the conditional relative frequency, When it's doing it by row, your marginal totals for your rows should all be 100. If you're doing the conditional relative frequency by column, then your marginal totals for your column should all be 100. Okay? Rows go across, columns go down. Pretty easy?
Yeah.
Okay, so now what that actually meant, if I was writing it as a probability, like if I was doing it by row, it would be like the probability of males who had computer. So like this one right here would be written like probability of male / computer. Okay, so if you were doing it, okay, like the one thing goes in the front and one thing goes after it. If you were writing the probability notation stuff, which we'll talk about that more when we're reviewing all this next week. Okay, so everybody should be finished with 11.3, correct?
Yeah.
Okay. So now we are on section 11.4. Now, there's a review in here, so you gotta kind of skip past the review. And 11.4 is on page 526 is where it starts. Okay, 11.4, instead of frequency distribution, this is called probability distribution. Okay, so there's some definitions we need to kind of talk about. Frequency distribution showed you how many times something was in there, how many times you had an outcome. So that was these. You had the numbers. The probability distribution usually has it either as a percent or as a decimal. Okay, so frequency, it's just the numbers, how many times something occurred. The probability is focused on the percent or the decimal version of it. Okay, now there's two types. That's what we're talking about down here at the bottom. Okay, on page 526. There are two basic ways to record numerical information: counting and measuring. Counting means I can sit here and count how many posters I have sitting on this desk that I took off my board. I can get a final answer and count it. Okay. Measuring means I actually have to use something to measure it. Okay, if I wanted to measure how long one of the posters were, then I have to use a ruler or something to measure it. Okay, so if I can count it, it's called discrete. If I can count it, it's called discrete. These words are down there at the bottom page 526. You just need to know the difference between these two, because this is the first type of problems that we're going to be working on. If you can count it to separate it into different items, it's discrete information. It can be counted, separate items. If it's continuous information, then that means it must be measured. So if I'm talking about the length of my board, that has to be measured. So that would be continuous information. I don't have separate little individual pieces of the board. I have one big board altogether. Okay, if I want to talk about how tall the school is, I'm talking about the height, it has to be measured. If I'm talking about anything that has to be measured, how much something weighs, weight is a type of measurement. Those are continuous. If it's something that can be counted, how many books are on the shelf, how many students are in the room, how many cards are in the box, it's discrete. If it's something that has to be measured, how tall the building is, how much something weighs, then those are continuous. So that's the first type of problems that we're dealing with, okay? So if you look on page 531, we're going to talk about those first four problems there. Because on 531, All we are identifying is whether the information would be discrete or continuous. So discrete, again, means it has to be counted. Continuous means it has to be measured. Discrete is counted, continuous is measured. Okay? So, number one, from what I've just said, Aurelie, number one on page 531, heights of city buildings, is that discrete or continuous?
Continuous.
Continuous, because you would have to measure how tall the buildings are. Okay? Number two, Jazaria. Amount of water in a container.
Discrete. Oh no, continuous.
Continuous, because if you're talking about filling something up, you're talking about its volume. So that's a measurement. So that's continuous.
Add those up, tell me what you get. Johnny, add those up, tell me what you
So let's see, Yaneli, number three, the number of cookies in a package.
Discrete.
Discrete, because you actually can count how many cookies are in a package. I wish I had some cookies right now, but anyway. Sounds good. I've been craving chocolate. Anyway, all right, and then number six. Number six. Number of dogs in a kennel. So Micah?
Discrete.
Discrete, because you can sit there and count how many dogs are in there. Now, if they're all running around like crazy, it's a little harder to count them, but you can still count them. Okay, so if it has to be measured, whether it's length, height, volume, whatever dimension it is, if it has to be measured, it's continuous. If you can count it, it's discrete. Okay, now, the next thing that we're going to talk about is there on page 527. A discrete probability distribution is a probability distribution in which the outcomes can be counted. For example, the number of people living in a household or occupied housing unit in the United States can be counted. A household cannot have 3.8 people. Okay? You can't have part of a person. Okay, there's either 3 people there, 4 people there, not 3.8 people. The table shows the discrete probability distribution of U.S. household size in 2011. Okay, so you see it has the number of occupants, and then it has the probability out of the total. Okay, you have the number of occupants, and then you have the probability that is out of the total. Okay, so if it had 1 occupant, that made up 27.7%. If it had 2 occupants, it was 33.6%. Okay, so that's your percentage. Now, a lot of times for these, it gives it to you as a percent, but when it's wanting the answer for the question, it wants it in decimal form. So what do you do to the percent to change it back to the decimal?
Put it back.
Goes back 2 places to the left, right? Your decimal point. So that's what we're going to be doing on these next problems. So for number 9 and 10, that's what we're doing. Okay, so we're back on page 531, the problems. Okay, on page 531, the problems, it has a probability distribution there for you. It says Julian took a survey in his neighborhood to find out how many dogs each household had. He then took his data and created a discrete probability distribution. Use the data in the table below to answer the following questions. So you've got your number of dogs. They either had 0 dogs, 1 dog, 2 dogs, or 3 or more dogs. And you have your total. And he gave his probabilities. We don't know how many households he asked. We don't know the total, but we know that the totals of the percents that he calculated had to add to equal 100. So we don't have all the exact information. We just know what he got as his percentages. So for number 9, it says, what is the probability that a household will have exactly 2 dogs? So the probability, and they use the letter X, probability that X is equal to 2. So if you look at his table, 2 dogs was what percentage?
19.4.
19.4%, but we move our decimal back 2 places, so it's 0.194. Okay, so that is the probability that the household has exactly 2 dogs. Okay, now number 10 is a little bit different. You're gonna have to think a little bit more, because on number 10 it says, what is the probability that a household will have more than 2 dogs? Okay, more than 2 dogs. So does it have 2 dogs? Do we include that one?
No.
No. So we're on the probability when X is greater than 2. So from our table, that just includes which column?
The last one.
The 3 or more. So the percent on 3 or more was 5.7. When I go back 2 places, I'm going to have to add a what for a placeholder?
0.
0, so it's 0.057. Okay. Now, what if I wanted to know how many households, and this isn't one of the problems, I'm just asking you. If I want to know how many households had less than 3 dogs. So if I want to know how many have less than 3 dogs, am I going to have to add some columns together?
Yeah.
Yeah, because if I want to know the probability of X being less than 3, that's going to mean they either had 0 dog, 1 dog, or 2 dogs. So I would have to add all those together. Okay, and so if you get one like that, that's what it's talking about. If it says less than 3, that means you could have had 0 dog, which was 31.7. You could have 1 dog, which was 43.2.
94.
Or you could have had 2 dogs, which was 19.4. So you would have had to add all 3 of those together and then change it to the decimal. Okay? Everybody kind of get that concept? Yes, no? If it says
Yeah.
3 or whatever. Okay? So that is the discrete probability distribution. Okay, that's the discrete. Okay, now we're going to talk about a different kind. Okay, if, okay, that was discrete, that was on page 527, we'll talk about those. Then it has a probability histogram. Y'all remember histogram? Those look like the bar graphs, but the bars are touching. Then we have a continuous probability distribution, and a uniform probability distribution. The one we're focused on now is a uniform probability distribution. So that's what we're going to be doing to answer 13 and 14. Okay? So for a uniform probability distribution, it means, uniform means alike. Okay, they're all the same. So if I have a spinner that has 5 sections that are all the same size, each section has the same chance of happening. Okay, so it's uniform. They're all the same size. If I have dice, everybody knows what I mean by dice, or number cubes, okay, because they don't like using the word dice, because some people think you're talking about, okay, you can have dice. But anyway, they all have, each size of the die, singular, is the same, so they all have an equal chance of happening. So it's uniform if they all have an equal chance of happening. So that's what we're doing for 13 and 14. It says a spinner is numbered at equal intervals. So that means all sections of it are the same size from 0 to 10. So you'll notice I drew my little graph up here already that goes from 0 to 10 across the bottom. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for each section, representing each section of the spinner. Then it says each value is equally likely to occur. Since they're all the same size, they all have an equal chance of happening. Construct a uniform distribution graph for the spinner. Use this graph to answer the following questions. So that's what we're doing. Now, if there are 10 sections, what is your chances of getting a 5? Out of our probability stuff that we've been doing this past week or so, what's your chance of it landing on a 5?
1 out of 10.
1 out of 10, right? What's your chance of landing on a 3?
1 out of 10.
Out of 10. All of them have a 1 out of 10 chance because each section's equal. So you'll notice on the left-hand side, get y'all up close and personal. All right. On your left-hand side of your graph, it goes from 0 to 1. Okay? So this is 1/10, 2/10, 3/10, 4/10, 5/10, which is half, 6/10, 7/10, 8/10, 9/10, and then 1 is up here at the top. I just drew on my little line. Okay? So, because it's 1 out of 10 chance, right? So my little number down here, my first one is my 1/10. That's the chances I have since each one is equal section. Okay? Now, what we're doing for number 13 is it says, what is the probability that the spinner stops between 3 and 4? So here's 3, here's 4. So if it stops between 3 and 4, it would be like it's in that section right there, right?
Yeah.
Yes or no? Okay, so to find our probability for that, you're finding the area of that little section. That little section is what shape?
Rectangle.
A rectangle. So to find the area of a rectangle, you take its length times its
Width.
width. So our length from 3 to 4 is how long?
1.
1. And our height going up here is
1/10.
1/10. So your probability of it landing between 3 and 4 is, multiply that together. So probability that it's between 3 and 4, okay? Probability that's between 3 and 4 is your length times your width, or just 1/10. So that's using the uniform probability distribution. Number 14 says, what is the probability that, I saw something about dogs again. I was reading up too high. I was like, this didn't have dogs on it. This was a spinner. What is the probability that the spinner will stop between 1 and 4? So instead of just 3 and 4, it can be from 1 to 4. So it's all of this part now. So instead of just being 1, how long is it all the way across there?
3.
3. You got 3 sections. So my probability that it's between 1 and 4 is 3 times 1/10, or
3/10.
3/10. Okay, so that's using the uniform distribution. Blah, blah, blah. Okay, so everybody should have 1, 2, 3, and 6. We should have 9 and 10, plus we talked about others with that. You should have 13 and 14 with your graph. Okay, so there's 2 problems left. Okay, number 17 and number 18. Number 17 says, Susan counted the number of vehicles that passed a particular stop sign. She counted how many vehicles stopped, how many vehicles slowed down but did not stop, and how many vehicles did not slow down or stop, which you should not do that. If it's a stop sign, you should what? Stop.
Stop.
That's what it means. Stop. Okay. Oh, yeah. She created a discrete probability distribution for her data. Use the table below to find the probability that A, a vehicle would stop at the stop sign, and B, a vehicle would break the law at that stop sign. So, okay, the only way that you obey the stop sign and you do what you're supposed to is if you actually stopped, right? So for number 17, the probability that they A, stopped at the stop sign, okay, the probability that they actually stopped at the stop sign is going to be what?
.6%.
Okay, because the probability that they stopped is 6.6%, but we always change it back to a decimal, so it's
Decimal.
0.066, right? Now,
Yeah.
the probability that they broke the law, that's part B. Okay, you broke the law if you did what?
Didn't stop.
Didn't stop. So if you slowed down, you still didn't stop. Okay, so you have to take those two columns like I was talking about over there. If you had the number of dogs less than 3, you're going to have to add some stuff together. So we're going to add together the ones that slowed down and the ones that did not slow down. Well, good Lord, a lot of these people broke the law. I don't know where they live. Most of them broke the law, didn't they?
Yeah.
Okay. So you're going to have to add those two together and then get it as a decimal. So 51.6 and 41.8.
93.4%.
Okay, and then we move our decimal point over, so it's 0.934 is the probability that they're a lawbreaker. Okay, so apparently it must be a new stop sign that people aren't used to having to stop for or something, because, or otherwise they're all bad drivers there. It's one of the two options. Okay? Oh, my pencil's wrong way. All right. So, next one. 18. 18 says, a spinner is numbered at equal intervals from 0 to 6. Okay? Each value is equally likely to occur. Construct a uniform distribution graph for the spinner. Find the probability that A, the spinner will stop between 2 and 3, and B, the spinner will stop between 1 and 4. So this is similar to what we just did for 13 and 14. Okay? This time it goes from 0 to what, 6? Yes.
Yeah.
So I have 0, I have 1, I have 2, I have 3, I have 4, I have 5, almost drew it long enough, I have 6. And then going up the side, it's, if they all have an equal chance, the equal chance would be 1 out of 6. So my little line over here is going to be 1/6 for this one. Okay. Now for part A, it wanted the probability of it being between 2 and 3. Okay. Probability of it being between 2 and 3. So if it's between 2 and 3, how many sections is that?
2.
How
1.
many sections is that? That would just be like what we did on 13. It would just be from here to here, right? So that's just one section. So I have 1 times 1/6. So my probability is 1/6. Now, you can always change this to a what? A decimal. Most of the time with these, they want it in what form?
A decimal.
Form. So if you take your little calculator and you change 1/6 to a decimal, you get a big long repeating decimal, right?
Yeah.
Okay, so do it.
Points.
Of it all,
0.167.
1/6/7. Okay. Now for part B, it wanted to know the probability of it being between 1 and 4. Okay. So if it's between 1 and 4, that's from here all the way down to there. So how many sections do I have this time? 1, 2, 3 for my length times the 1/6. Why am I putting that like that? I do not know. 3 times the 1/6. So that's 3/6, which is equal to what?
1/2.
1/2, which would be
0.5.
0.5. Okay, pretty easy. Yes. Okay, did any of y'all hear anything from Naomi else after she lost? I don't know if she lost internet or what. She's been gone almost the whole time, so she was there. But, I mean, she hadn't sent me anything saying she just lost internet or anything, I don't think so. All right. I don't know, I've got so many emails. I can't keep up with y'all. All right, so
Ellen,
what?
I have a question. Not a question, but yesterday I tried to redo my quiz 36 and 35, and it wouldn't let me. But it let me redo my test 10 and quiz 34.
Yeah, I thought you were in there redoing all of them.
I was, but then I tried to redo quiz 36, and I think it was 35.
Let me, hold on. I'm looking at my book because I wrote down. Yeah. Now, it lets you redo them. It's showing that you redid everything except quiz 30. Well, I don't know. Now, I've got quiz 34 and 35 that you redid it.
Yeah, I think it was just quiz 36.
Okay.
You went for midnight?
All right, I'll check the settings if you mind go back in there today. But the test, you shouldn't have had any trouble redoing it because I'd already done that where you should have been able to have the.
Yeah, I did it.
Okay. Did everybody else go in and try to fix stuff? I know I really took one of them like 3 times.
Miss, I failed. No, that was Yaneli, but I failed.
It wasn't. She was driving.
I have Aurelie took one of them 3 times. I have Yaneli took 2 of them 3 times. Or no, one of them 3 times. Another one twice. Okay, but if you haven't, if you need to still go in and redo that test and stuff, I'll double check the settings when we get off here today, but it looked like most of you were able to get in and do that. So make sure that you have if you need to, because, you know, some of them weren't very pretty. So, because I have them open until like 9 o'clock tonight. I think it is. Okay. So if you need to, because you have bad grade on it, you need to do that because progress reports are going out next week. That's why I was trying to give you all the chance to go back in and redo that. Okay? To help your grade. Okay? All right. So double check that. Make sure you can do that. As far as for work on Monday, of course, it'll be listed in My School Works that you're supposed to log in and check how many times a day? 3 times. Okay? You're supposed to try to log in and check it like 3 times a week. 3 times a week, no, 3 times a day. In the mornings, at lunchtime, in the evenings, okay? So I'll have stuff in there, but you're gonna be working on that review. Remember, we skipped over a review between section 11.3 and 11.4. So I'm gonna have some of those problems from that review that I'm gonna ask, that's gonna be your work on Monday. So then on Tuesday, when we log in for class, I'm gonna say, okay, show me your review problems, and everybody's gonna have to hold their thing up so I can see that you did your work, okay?
Alright.
Okay, so for those that aren't in here, please make sure they know as well, plus it'll be in My School Work. So make sure if you do need to still try to take quiz 36 again or fix it and test 10 that you do so. Like I said, I'll go double check the settings and see what they're on to make sure it lets you do that. But they should be there till like 9 o'clock tonight. Okay? Any other questions on that?
Oh, man.
All right, we're all good? Okay, so we'll see you on Tuesday.